Hi, hello everyone. Good morning, good afternoon, and good evening to whichever part of the world you are. A very warm welcome to each one of you for today's live session on Data Preparation 101. This is a part of our machine learning bootcamp, which we started along with in collaboration with AI Engineering YouTube channel, which was started by Srinivas and Srivatsan. And coming to our guest speaker today, it is Aarthi. Aarthi is a lead data scientist at Allianz Belgium, where she applies data science for solving sales and marketing problems in the insurance sector there. And she's also an ex-entrepreneur who has hands-on experience in business intelligence, machine learning, and deep learning. We thank her for joining us today. And not just that, she also contributes and gives back to the community in her spare time. She's also an evangelist, and she's currently associated with Women in Data Science, where she's an ambassador. With that, I'll let Aarthi take over the session. Aarthi, it's all yours now. Thanks for joining in.
Thank you, Chanakya, and thank you, DeFi, for giving me this opportunity. Hello, everyone, whichever part of the world you are in. Just a small note and probably a request from my end. Women in Data Science is an initiative by Stanford. So every year we do a conference on 8th of March on International Women's Day. And 2 months prior to that, there is also a datathon that happens in Kaggle. So this year it is going to be on medical data, and the registration has been opened up for this. So I will ask Chanakya and DeFi team to share the link in the community website where you can sign up for this datathon. It is open to everyone, but it has a small condition that 50% of the team should be represented by women, because this is an organization to promote and encourage women to participate more in data science. With that note, I'll get started. Chanakya, you're able to see my slide that I have shared?
Yes, I'm able to see. It's perfect. You can go ahead. Yeah, thanks.
Okay, great, thanks. So I want to start with a little bit of myth versus reality. That is the job of a data scientist, because we are going to bust a lot of myth and answer with the data. So on a funny note, this is what people think we do, but what we actually do is this. What that means is we end up doing a lot of data cleaning as compared to the other work. So before that, I will go on to explaining a little bit of this machine learning process. So we start with the business objective. We gather what data that we want. We collect the data. We do a little bit of exploratory analysis, understand the data, prepare the data, and then move on to the model building, evaluation, and deployment. Today's focus is going to be on this, which is exploratory data analysis and data preparation. We assess data quality and clean. We transform the variables, and then we split it into train and test so that it is ready for modeling. And this is a very iterative process, because we go back from the modeling phase. We understand the data. Some information could have been collected, and some information can be transformed better. So this entire 4-step is actually very iterative. And what happens in reality is that 79% of the time in any machine learning activity is spent on data collection and data cleaning. So that is why this is a very important step to keep in mind before we move on to the modeling phase. What is data preparation? So data preparation is the process of collecting data from several sources and then profiling, cleaning, enriching, and combining them to derive a holistic set that can help you in your model. So profiling is in understanding your data. Cleaning is, of course, if you have any quality issues, you clean and enrich the data. If you can see if you can add more data from external sources, right? Like we have a lot of open data sets today, and the government also keeps publishing open data sets. So can we use those to enrich our data set and combine all of them into a derived data set for using an analytical process? Why do we need data preparation? Garbage in, garbage out. This is something that you will always hear, because what you feed your model is what you get out. So you feed poor quality data, and poor prediction is what you get. And poor models lead to poor decisions, and poor decision costs a lot to the business. As per Gartner's survey, that is almost to the tune of 15 million in a financial year. Understanding the data. So understand your data from the perspective of solving the business problem. So the first question that you need to ask is what problem you are solving. So are you, for example, predicting the COVID number? Like how many how many people will get test positive tomorrow? Or are you going to like predict an occurrence? Like, is it going to rain tomorrow or not? So you need to understand your goal to be able to understand your data as well. And then you need to separate the data from noise. This will also be covered in model evaluation, because some of the models are very good in handling the data from noise. So are you using relevant variables? For example, now it is very easy to collect a lot of data, and storage is also cheap. But using the right data is only going to help in improving the prediction. Are the variables you're using has an impact on the business decision making? Like, for example, can the business do something if you give, let's say, a feature importance of that data? So, for example, let's say it's a salesman who's trying to sell more, and you are going to like say, yeah, a particular location A has more probability of selling. There is only so much he can sell in that place. At one point in time, it's going to saturate and he has to move on to location B. So then you need to focus more on the customer aspects than on the aspects which the business cannot control. And using all the columns could also cause discrimination. This is something that has been getting a lot of attention in the recent past, is the models carrying the bias of the human beings as well. So the models are also discriminating as much as we do. So especially like gender, race, economic status, etc., are all very sensitive data, and be very careful in using those in model building. Assessing the data quality. So there could be a data type error. For example, a text column can have a number column can have a date, and data format error. So like, for example, a date format, is a DDMM or MMDD, or is it totally something else? And missing values. So sometimes there could be errors in the data, so that the data points might not have been captured. And then outliers, anomalies, like extreme values that can occur in your data. And then duplicates. We will cover each of these along with hands-on code and data set. We will take the Titanic data set for this. This is one of, good knowledge data set. This is about some of the variables from the Titanic survivors. So this is about predicting whether someone survived or not based on their, few variables, which is, let's go through one by one. One is the class that they were traveling in, first class, second class, or third class, whether it's a female or male, what is their age, how many number of siblings were traveling along with them, or how many number of parents and children were traveling along with them, the ticket number, how much they paid for buying the ticket, which is a fare, cabin number, what is their allocated cabin number, and where did they embark, where did they board the ship. 3 locations in the United Kingdom, which are denoted by the alphabet C, Q, and S. So I'm going to move on to the Jupyter notebook now. So one check, Chanukya, you're able to see the Jupyter notebook and the zooming in is fine?
Yes, yeah, able to see.
Okay, okay, great. Some of the libraries that we will use in this is pandas. This is good in doing all sorts of table calculations, very similar to Excel or SQL if you have already used that. NumPy, it's a data analysis and data manipulating tool. Random generator and visualization tools. So we will see where this is being used at the end. So let's start with importing the data. So our data is in a CSV format, and then we use read_CSV to import our data, and shape will give the number of row and columns in your data. So this is like a matrix. So in this example, so you have 891 rows and then 12 columns, and then you have a training data and the test data. So here you have 418 rows and 11 columns. What is the difference? In training data, you have the 12th column, which is your target variable called survival. So whether someone survived or not is denoted by 0 or 1. And that is not there in your test data. Why? Because the model will learn from the trained data and then predict it on the test data. So you will be predicting the survivor probability on the test data. So that's why you have one less column. And .d types will give you the list of columns in your data sets along with their type. So integer, int is like integer, it's a numeric with a decimal. Object is a string. Float 64 is a whole number. And then let's look at like the first column content. So there is a passenger ID, which is like 1, 2, 3, 4, 5. So it's an index. Survived, so it's a 0 or 1. P class is again 1, 2, 3. So first class, second class, and third class. It contains name with salutation, and then whether that particular
One
passenger.
quick thing.
Yeah.
Yeah, sorry to interrupt. So can we go a little slow on the pace? I mean, that's the request from some of the participants. Yeah.
Sure.
Yeah,
I will.
yeah. I think it's going great. Yeah, thanks a lot. Yeah.
Sure. Thanks for that feedback. So what we have here is the sex, whether someone is a male or female, and then age, how old are they, and then the siblings versus spouse. So for example, this person, Mr. Owen Harris, is traveling with one sibling or a spouse. So this is sibling or a spouse. He's not traveling with any parent or a child. So that's why PARCH is 0. And then a ticket number, and then how much he paid, and then what cabin number. So NAN in the data set means missing values. And then where did he embark? So it's in S. So it's in Southampton, right? So train.head will give you like the first 5 rows. You can also determine how many rows you want to see there. If you want to like look at like the first 10 rows, that will also happen. Another thing that you need to keep in mind is the index in pandas will always start with a 0. It doesn't start with 1. So that's why here you see when you ask for 10, you get like 0 to 9. Okay, and maybe I can quickly open this data once in an Excel file and then show that as well. So this is how our data is. So this is what we end up seeing in the Panda. So this is a comma separated file, CSV file. So each column is separated by a comma, and read.csv will automatically identify the separator and then read it into a pandas table. Right. So moving on, we want to assess if there are any missing values in our column, right? So train.isNull. So this is going to take into consideration all the columns and sum the number of rows where it is null, right? So, and then what we are seeing beneath is we are printing only the columns that has, blanks. Maybe if I can show. So the output will come like this. So wherever you see 0, there are no missing values in these columns. And in age, cabin, and embark, we have missing values. So that is what we need to understand in detail. And in number of rows, it is 177, but in proportion, it is 19.8%. So 19.8% of our data has missing age. 77 of them have missing cabin, and negligent percentage has embarked also missing. We do the same analysis on the test data as well, to understand how the test data is also, are there any missing values in test data which we need to impute before we load it into our model. Train.describe. Okay, so what this function will do is it is going to take all the numeric columns and give a summary statistics on those columns, right? For example, passenger ID, survived, B class, age, siblings, count of parents or children fed. These are all the numeric columns in our table. So when I say numeric, it will take both integer and float as well. And count is number of rows. Mean is the average. Standard deviation, so how much it deviates from the mean. What is the minimum value? And this is 25%, 50%, and 75% are quartile. So the 50% is usually our median. And then we have the maximum value in this. So passenger ID is it's a ID column. So that's why you have like 1 as a beginning and then 891. So it's an ID. So it's 1 row per incremental row. Whereas survived is actually a categorical column. It's 0 or 1. And there it is doing an average of that as well. Similarly, P class is 1, 2, and 3. It is also a categorical column. We will later see how this can be converted. And then age is a number that we want to understand. So 714, because the remaining is missing. The average is 29.6. That's the average age of people from our data sets. And it deviates 14.5. So 29 plus or minus 14.5 is the standard deviation from the mean. And then you have the number of siblings, parent or children, and then fair as well. So if you look at these, you can understand how the data is spread. This is also something for people who don't want to code. Sorry. So this is a GUI option for pandas. So running this on the data set is going to help me, look at my table. And then it helps me in adding filters. If I want, instead of coding, you can add your filters over here. You can look at the same summary statistics that we added, like from dot describe. And then this helps in creating the column. So for example, we can choose histogram, and let's look at the survived column, how this is distributed between people who survived and people who didn't. So when I drag and drop this on the x-axis and color on the y color variable, so it's going to give me a graph, which is this is how our data is distributed. So 549 people survived. Survived is equal to 0. So 549 people died, and 342 people survived. So this is my data split. And you can use this for any other column. So if you want to like add, one more variable to it, you can do so by creating like a bar or a box plot, whatever you want. So this is like a good way if you don't want to get started with coding. This gives you a platform to play around with your data to understand your data. So we also have to understand the categorical variable. So sex is a categorical variable. So what we mean by a categorical variable is anything that is not unique, not numeric. It is a text column, and it is going to frequently occur in our data. And we need to understand how many times it occurred, what is the proportion, what that column means. So value counts will actually count the number of times it occurs in our data. So in our data split, 577 observations are male and 314 are female. Similarly, in Embark, majority of them, 644 of them, boarded from Southampton, and a few of them from C and Q, the other two locations where they boarded. And survived, 549 and 342. So this is what we checked in our GUI bar graph. And then the percentage. So 61% of them did not survive, and 38% of them survived. And dropping irrelevant columns. So what are we trying to do here? We are trying to predict if someone survived or not. So few of the things that are going to help us in predicting that is which gender they belong, because if you have, of course, seen the movie, they try to evacuate women and children first. And then the age, they also try to evacuate the elderly people first, because the younger can survive the temperature as well as can swim for some time. And also the class matters, because this is how there were decks in the ship, and you had like third class, second class, and first class in like different levels. So depending upon which part of the ship they were, if they were on the side of the ship where the iceberg was hit, So the water was flowing faster and flooding the lower levels, so which is usually where the third class and then second class and the first class. So that is going to help us. But a name of a person is not going to help us. A ticket number, like, so we don't care about the ticket number. These two are irrelevant, information. And then passenger ID, so we have the ID that is already created by pandas. Sometimes this passenger ID can also be used as an index instead of the ID created by pandas. In that case, you can use set index as a code and give the column name, which should be taken as a index. Like, for example, if you're working on a website data, the session ID could become the index, and then you can connect back to the session ID for prediction later. So yeah, now looking at the train data, so we saw that we had like some missing values. Sometimes the numeric missing values could be 0. So that is something that we should keep in mind. Let me go back a little bit to the.
Aarthi, one quick thing before we jump in, we have a couple of questions, if you don't mind addressing them. So one is basically, I think people are asking about when they should split. I mean, when they should split the data before splitting it into, when they should go with the with. Okay, so basically they wanted to know when they should split it into train and test data before imputing the missing values or something. Yeah.
Okay. Usually, yeah. So in this case, we had the train and test data separately from Kaggle, but you always do the missing value imputation, data cleaning, everything on your data first, and then split it. We have another example on that as well, on how we split it, so which will also be covered later. I will emphasize there. But ideal scenario is to do all the data cleaning, data preparation stuff on the whole data, and then split it into train and validation. Any more questions, Chanakya?
No, and the other thing is, people just wanted to know how did we land into a GUI? I think you just imported that, right? Probably if you can show that once again.
Oh yes, I will. I will. Yes, sure.
Yeah.
So this is okay. So pandas is the okay, maybe. So pandas GUI is another package that we have. So we import show from pandas, and then we use show of our data sets. So train, DF, whatever your data set name is. So the moment you do that, it is going to give a pop-up, which is nothing but, instead of looking at it in a Jupyter notebook, you look at it in a better user interface screen, like how you do it in your Excel file. And you can, so this is the data frame that you see. And another one is filter. So where if you want to like filter for a particular age greater than 20 or age less than 1, if you want to look at the babies. And then like some summary statistics. It will also give you the type that I showed as .d types. So basically this is a better thing if you are new to Python and pandas, to just load your data, which is read_CSV. Let me go a little bit back. So here you load your data and you assign it to a variable called train. And then immediately you can go to this pandas GUI and then display it as a GUI, so that all the D-type, describe, visualizations, that instead of doing it by code, you can do it in a better interface. Because programming is the easiest part that you can figure out. Understanding the data and asking right questions from the data is very important. So please focus on that rather than understanding the code when you start, because coding is always, you can get some help from Google, but domain knowledge and experience is what you gain by more and more practice. And similarly here in the graph also, maybe I'll do it one more time. You select the graph that you want and then drag and drop on the x-axis the variable that you want. The same variable, if you don't put it on color, what you will see is the single color, but between 0 and 1. And if you drag and drop it on the color, you're going to see it in like different colors, but it's all the same. And if you want to use a different bar graph, if you want to like how many people survived. Oops, sorry, I should have put that in color as well. My bad. Okay. It's taking it as a numeric column. That's why it is giving a grade. But otherwise, it will give you a distinct color between how many people within female who died and survived, and within male who died and survived. Oh, is that okay?
Yeah, yeah. Also, one quick question. How does the describe data reveal, or how do I read this? 25% died, did not survive, 50% died, did not survive, and 75. Yeah.
This
So
one?
maybe describe data, I think.
Yes, this one, train.describe.
Yeah.
So what this does is it just takes all the numeric columns from your data. So this does not split your data between numeric data or categorical data. So sometimes you will have ranking 1, 2, 3. So the 1, 2, 3 doesn't mean that you have to add all the ones together or twos together or threes together. It is not a numerical data but a ordinal data. So pandas doesn't know that difference. So in this case, what you need to do is you need to use a string function to transform this from a numeric. So survived is a categorical data. So zeros and ones have a yes or no meanings. So because it's a 0 to 1, it is reading as a numerical. We need to convert it into a text data. So that's why I said passenger ID, survived, and P class. Please do not look at these values because these would have been categorical. But look at the age. So the average age of people who were there is 29.6, and the maximum age is 80, and the minimum is 0.42. 0.42 means like those many number of, it's a month's old baby that was there on the ship. And then similarly, number of siblings, number of parents. This is also something that you can make sense because these three are originally a numeric data as well. And then the fare. So this is also a numeric data. So the average ticket price is 32 pounds, 32.2 pounds in Titanic. The highest price is 512 pounds. So that must be from the first class. And the minimum is 0, which means here what you need to make sure that, okay, someone cannot travel for free. Maybe that is a missing value. So the numeric data's missing value may not be always NaN or blanks. It can also be 0.
Thanks. Yeah, okay. I think we can carry on. Yeah, thanks.
Sure. So maybe I'll go through everything once a little bit. So yeah, we looked at the percentage of survived versus not survived. So 61% of the people did not survive and 38% survived. We are deleting irrelevant columns for our data. So the columns that does not make any sense being in the input for model building. So whether someone survives or not is not going to be based on their name or the ticket number or even their ID that they were using, right? So these are the columns that we will delete because irrelevant column reduces, it's actually a cost on your model. It reduces the predictability. And here, so few missing columns in the fare. So let me go back to the slide because there are a few things that I want to show as well. Oops. Yeah. So how to fix data type error? So for example, numerical value in a string column or string value in a date column. So if this error is at the source data level, it is difficult to fix because you need to go back and correct it at the source system from where you're extracting. Some data quality checks is at the data collection stage itself is important. For example, if you are setting up a form or something to collect your data, you can put data validation checks. So most of the time you would have seen if you have to enter your OTP in banking website, it will automatically show only the numeric keyboard in your mobile phone instead of a QWERTY keyboard, right? So like that, you can fix the data quality at the source stage itself. Treat them as a missing value because once it is in your data, if it is from the source system and you can't go back and fix it, you have to treat it as a missing value and impute it. We also see how to treat missing values later. How to fix data format error. So for example, if you see a GDMMYY in a MMDDYY column, so how do you see it? Sometimes this could also be because the data would have been collected in a MMDDYY format. You might get that data in an Excel file, but your system settings could be in the other format, DDMM. So in that case, what you can do is you can import that as a string column. And then once you know the existing data format, you can use that. Like for example, this function to date time will convert a string to a date function, date field, and then it'll take an input, which is this, and you also give what format your data is in. So you're saying it is DMY and then HMS. So if it is just a DMY, then you will remove all this HMS. So you can specify in which format your data can be in what format your data can be read by the pandas. Missing values. So these are the missing value treatment. So what we can do is we can either delete it if there are not too many there, or we can impute it. What impute means is you fill in for what is missing by making some assumptions or calculations. Deletions means pairwise deletion. So you only delete the missing value. For example, in our column, we had age missing. So the pandas by default calculates the mean by ignoring the missing value. So if we had 890 values in our data set, but only 770 have age, the average will be divided, sum of age divided by 770 instead of 891. And list-wise or dropping entire row. So if something is blank, you can delete that row. And you can drop the entire column. So if there are too many missing values, but that's a problem only for that column, and remaining columns are intact, then you can remove that column. And when you impute, there are two different. One is a general or simple format, and another one is advanced. Advanced is like where you create an algorithm to fill it. But let's look at a simple imputation for today. So for a non-time series data, you either impute it with a constant. For example, if you want to be able to, if you know the business problem and if you don't want the model to mistake that with something else, then you create a different constant, and then later in the model, you will be able to filter out based on that constant and look at those observations alone from the model prediction. Similarly, imputing with mean, median, or mode. So if it's a numeric value, you can impute it with mean or median, and mode is most frequent occurred. So for categorical variables, you can do that. So for today, we will look at deletions, like if we are going to delete entire row or a column. And then we will also, look at imputing with a constant or a mean or median. Going back to the all right. So we saw there are missing values, and yeah. So this is an example for deleting the rows, right? This is dropping entire rows or list-wise deletion. So we have a pair that is equal to 0. We consider that to be a missing value, and then we drop it. So train.shape, what is the size of my data before I delete those rows? It was 891 rows. And after, I have 876. So we are not losing too much, about less than 20 rows over there. And then we can create imputation rules. So sklearn has a simple imputer. So this is, will calculate whatever you want, like a mean or median or mode. And then wherever it is missing, it will impute that value. So let me run through the code a little bit. So what we are doing is we are assigning the imputer function, and then we are saying what is the missing values in our data. So the data has np.nan. Instead of that, it is going to have 0. You can like specify it as 0 over here. Sorry, 0 over here instead of np.nan. So what you're telling the code is look for these missing values in my data, and then the strategy that I want you to follow is to average it. So look for blanks, average my column, and then replace that. So in this case, let us try doing that on age. So I'm saying like fit it on the column, my data frame and age, and then I'm assigning the new age column with this mean. So this mean dot imputer dot transform will identify calculate the mean, identify the missing values, and impute that. So similarly, categorical for embark, we are going to use the most frequent method, which is the mode. So what I will do is uh, I will do this and also show you how it will come in the output data. Right. So here. Right. This 29.645 is the average. So this was blank in the previous data. So if I have to like go here, so we had a missing value over here. So in wherever it was missing, this 29.6 has been imputed. And similarly for this embarked, so if you want to look at that as well. Yeah, so it has taken yes. So yes is the most frequently occurred value from what we saw. So it has imputed with the most frequently occurred for the categorical variable. Instead, you can also, this code, what is an alternative method that is being discussed here is a constant impute. So for example, you don't have to use the most frequent method. You can like say A or not available or something like that. So that later in the output of the model, you can still trace it back to the rows that had missing values. Okay, we are moving on from missing values to outlier. Any questions so far, Chanukya? Shall I proceed?
Yeah, I think we can proceed. But yeah, I think people were asking what does dot travel do, and also some of them were asking is removing missing values the best way, or like in typically like what do we prefer in the industry in terms of
Sure.
treating missingness? What are the
Okay.
best practices? Yeah.
Yeah, instead of dot ravel, I'm not going to get into the code too much. I'm also available in the DeFi Slack community, and you can also post in the discussion. So today's objective is to understand how the data preparation works, and how we can how it is being done, what is like the thumb rule, things like that. Regarding the code, I will take those questions offline, and you can reach out to me there. On answering the second question for how we deal with missing values, like I said, it is a very intuitive method. So the more you work with the data, the more you get better intuition, you can figure it out. But to begin with, so pairwise deletions you will use. For example, when you have when you don't have like too much of missing values, or that is not going to impact you in a way, in a bigger way. You drop again entire row. Here you need to keep in mind that you are not deleting too many rows. In our example, 20 less than 20 rows out of 890 is not a problem. But if you're going to have like some 100 rows that are going to be black, 100 rows are going to be deleted because of this, then it is a problem. So you're losing out more than 10% of your data. And in case of a column, yeah, this is one of the, if there are like too many missing values, it is better to drop the column, because you just have to assume that you don't have the data and move on, because dropping columns is better than dropping entire row. So in case of ordering, so you go from pairwise to column and then to entire row, and then again, with mean and median imputation, sometimes you need to also understand without the missing value whether your data contains outlier or not. So after this, I will cover outlier, but if your data contains outlier, then you have to do a certain methodology, and if it doesn't, then you have to use a certain methodology. You need to understand outlier first before that. Yeah, so mean, the problem with mean is it is in measure of central tendency, it is affected by outlier a lot, whereas median is a positional central tendency. So if you have an outlier or if you have extremely skewed data, it is better to go with median than mean. And usually you impute it with a constant when you want to be able to trace it back in the output of your model. So you want to know some probabilities. The model is built on some missing data, and the probability for certain observations could be a little flawed because you didn't have in that particular information. So you want to be able to look at that later. I think that's about it. Any more questions? One suggestion I would advise for people who are just getting started is to do all of these on your data and look at your model prediction. Finally, what is the accuracy that you're getting? Which method has a lot more impact on your model? And because of this missing value treatment, is your model output is getting an underfed or overfed problem? So if you do it iteratively for the same set of data, different methodologies, you start building an intuition over a time.
Yeah, I think Aarthi, we can move ahead. Yeah, thanks.
Okay, great. Okay, outliers. What is an outlier? In simple terms, it's an anomaly. So it's a rare event, or it's something that shouldn't be in your data in a normal scenario. Right, so we will generally define outliers as samples that are exceptionally far from the mainstream of the data, right? Like, so for example, in the age column in Titanic, if you had seen someone with the age of 110, then that's an outlier. So anywhere between 0 to 80 seems to be fine. Average, the age of survival probably in UK at that point in time was 80, but 110 or 115 is an outlier, right? So what is that you need to understand about outliers is that why does it happen in your data? So is it because of some input error or some fault in the measurement, or is it because of some data corruption? And then is it a true outlier? Should you still retain it in your data so that you also account for those outliers? So for example, Michael Jordan in basketball, or some other player who has an exceptional record will be an outlier when you compare it with the other people, right? Like if you want to compare Roger Federer or someone else, of course there will be a true outlier. So you need to keep that in mind. Of course, the other problem is that as this picture that sees over here, so you try to fit your data, but outlier might skew your data and take the model prediction accuracy for a toss. So this is why you need to treat the outliers. So outlier can be in numeric, string, and date. For example, let us look at examples for string and date, and for numeric, we will do a hands-on. String is if you have a city name that is mentioned in a country, or you have some gibberish data that shouldn't even be there. So that's a outlier. And date, so for example, you're only looking at last 3 years data, but in that you have something with date 1990, then that's an outlier. Sometimes outlier could also be because of missing values or data quality issues. So you need to keep that in mind. It can be a univariate outlier. For example, within the same column, you have exceptions. Like I said, age. Within age, you have some exceptions, right? Someone with 0.4, we saw almost months old baby to 80 years old. So within the column, do you see any outliers? So, and then multivariate. So you take two columns and then compare. And understand the relationship between them. So for example, in this, so what you see here, height box plot and weight box plot, And then like when you plot it together, so do you see any exceptions on the combination? You understand how height and weight evolves. It is almost always directly proportional, but do you see any deviation there? We use two methods. Today, we have many methods to detect outliers, but today we will look at two methods. One is the standard deviation. So when your data is normally distributed, your mean and median and mode are equal. So which is over here. Mean equal to median equal to mode. And then you have your standard deviation. Outlier is anything that lies on mean minus 3 sigma and mean plus 3 sigma. So 99.7% of the data gets covered in this, and 0.3% are outliers. So we will use this method to identify numeric outliers. And another method we will use is interquartile region. So quartile is the way is the division of data into four splits, 3 points and 4 intervals, and so this is a minimum to your Q1, and your Q1 to Q3 is the interquartile region. So your 75th percentile minus your 25th percentile will give you the interquartile region. The lower whisker is calculated by the Q1 minus 1.5 times of IQR, and the maximum is Q3 plus 1.5 times of IQR. So this is another method of identifying outlier detection. And median is what like your 50% is. This is another your central measure. So in this, it's a perfect fit. So where you have, this is almost normal distribution, but there are also cases where it will not be a normal distribution, whereas like your box will be skewed somewhere over here. Let's look at that as an example in the hands-on code. Some of the other outlier detection method are this presentation is already shared, and if you want to dig deeper into this, please feel free to reach out to me, or we will also share some reading materials for this, but these are the things that we will not cover today. I just wanted to show that there are different methods for outlier calculation. Okay, so two numeric data that we have is age and fair. Let's apply both the outlier methods to understand whether we have outlier in our data, right? So we are calculating the mean over here. So you take age column and then calculate the mean, and then you calculate the average. You calculate the lower end by multiplying the standard deviation with -3, so that you get the lower limit, and then you multiply it with +3 to get the higher limit. So our average is 29.6, standard deviation is 30, and minus 39.22 plus 39.2 is our range. Anything outside this will be an outlier. So here the problem is that, I should have done this plus. So I'm deducting 3 standard deviation from mean and adding 3 standard deviation from the mean. Oops. Oh, sorry. Yeah. So -9 to 68.7, right? So we have, sorry. So this is lower limit. We want to know if we have anyone below lower limit, and then we want to know if there are anyone higher than the lower limit in our data. -9 cannot be possible because age cannot be negative. So the maximum it could be is like 0, or it should be greater than 0. 0 still means missing. Sorry. Yeah. So we are checking if we have anything, greater than this in our data, right? So this is what we are checking with. Similarly, we are doing the same thing in the fair as well. So plus or minus code. The same thing Let us look at the IQR. So in IQR, we are calculating Q25, quartile 25, and then Q75. And then we are calculating the interquartile region and then the cutoff. So K is 1.5 times over here. So basically this code is doing the same formula that you see over here. So Q1 minus 1.5 times of IQR and Q3 plus 1.5 times of IQR. And then you want to filter out whether there are any outlier age, right? So here, if you do a box plot, what this is doing is it is taking fair column and from the data train, and then 1.5 times is the value that give. You can even do this for 3 as well, depending upon your data requirement, if you want to be really lenient or strict with your outlier treatment. And then this gives the box plot. So like I said, it need not be a perfect. It can be like this as well. Another example for multivariate is, let's look at the class and the fair, right? So within first class, second class, and third class, we are seeing if there are any fair outliers. So first class, second class, and third class, and we have some outliers over here. How do we treat outliers? Mean, median, or random imputation or constant imputation, very similar to how we did in missing value treatment. You can drop the values. This is also very similar to missing value treatment. You can put a ceiling on the outlier. So if you know about your data, then you can put a ceiling on that. So if you know the outermost limit, let's say it's a percentage column, and you know for sure the percentage cannot be greater than 100. So then you can seal all your, you can put a ceiling on all your outlier, where anything greater than 100 will take the value of 100. Bottom or zero encoding is when you know the lower limit for the data. Like if you know what is the lowest that your data can have, then you will remove all the outliers and replace it with the lowest value that your data can get. In the same manner, what zero encoding means is that if your data cannot be negative, like it's an age or it's a weight or it's a height, it cannot be negative, then you can put everything to be 0 or a little more than 0 if 0 is not a value that it can take, right? Another thing is you can bin the data together. I will show that as example as well. What binning means is you group your data. So for example, if there is age, so 0 to 10, 10 to 20, and anything greater than 70, you group it together. So even if you have 120 or 110 as an age, they fall under the last category. So that, this helps in reducing the impact of outliers on your model. Yeah, let me go back to the code.
Yeah.
So here, what we are doing is based on the minimum and maximum. Here, let us say we have like 5 bins, 5 groups that you want to create, right, on the age. So anything greater than all the outliers will get covered in bin 5. If you want to be a little bit more, lenient with your data, and you want to have the distribution in a much more granular level, you can change the bin to 10. And then, 9 and 10 might have your outliers, but the split between bin 1 to 7 is much more clearer. So if you want more clarity, if you want the data, the model to be robust between these, then you can use this. Again, this is also an iterative method, and you need to be able to practice different things on the same set of data to be able to understand how this works. Or any questions on the outliers?
Aarthi, yeah, before we jump in there. So there is one question, why 1.5 times of IQR or why 3? So you spoke about interquartile range, right?
Yes.
So I think there are some questions around it. Yeah.
So here, okay, this is the property of normal distribution. So here, 68, if the data follows a normal distribution, 68% of your data will get covered in mean minus 1 sigma to mean plus 1 sigma. And similarly, 2 to minus 2 times sigma will cover 95% of the data, and then minus 3 will cover 99.7% of the data. So this is for normal distribution. And again, this 1.5 times is a thumb rule. It can also be 3 if you know the data is inherently skewed and you want to not be very strict with your data. With 1.5 times, you can also make it a 3.
Okay. And what do you mean by outliers for P class? So maybe
There was
somewhere.
not an outlier for P class as is. But okay, yeah, I understand. So we are okay. What we are doing there is, it's in the notebook. We are looking at multivariate outliers, which means sometimes when you compare two data, so when you look at the data alone, you might not see an outlier. So if you look at the fair column alone, you might see, okay, it ranges somewhere between like 25 pounds to 2,500 pounds. It doesn't look bad to me. But if you want to look at it by another example, so for example, when you travel in a economy class and a business class, right, you will obviously not pay some 1,500 pounds or 3 lakhs or 1,500 euros for economy class, right? So economy class has a limit. Okay, it's going to range somewhere between 0 to 300 pounds, and 300 pounds to 700 pounds or 1,000 pounds is going to be my economy plus, and 1,000 pounds and above are going to be my business class, right? You need to check your data not just within the fair column but also with another column. So if I group my data by class over here, right? So are there any outliers? So is someone who's traveling in an economy class paying 1,000 euros, or someone traveling in a business class pays 250 euros? Let's say, as an example. Right? So that's why multivariate analysis helps, where standalone, if you look at a column, they might not have a weight outlier, but if you look at it with another column, then you can find the outlier or data quality issues. Let's say another example where based on the age, you are categorizing people as infant, teens, adults, and senior citizens, right? If you compare age and that category from your data, if a senior citizen in one column, there is senior citizen in one column and the corresponding age is 5, then that is an outlier, right? That's a problem. It is either a data quality issue or some error, or maybe you need to recalculate that teen or a senior or an adult column again from your age, if your age is correct. So that's why here in the Titanic example, we are comparing the passenger class 1, 2, and 3 with the fare to see if first class people are paying like a little less, or the third class people are paying a lot more. So this is just an example that I wanted to show for multivariate. Is that clear?
Yeah. That's fine. Yeah. Thanks.
Another question?
We can move on.
Any other question?
No, I think we are done with it. I guess I think we
Okay.
can go through. Yeah. We can carry on.
And also help me keep a tab on the time as well. So this is
Sure. Yeah.
Okay. Duplicate data. Sometimes your data might have duplicates, and you have to remove it to avoid overfitting problems. But before removing that, you need to keep in mind that they are not real data that coincidentally have values that are identical. For example, if you want to, let's say you're running a website and you're selling something on your website, you have people coming to your website without even logging in. So in that case, you will have something called session ID, and each person who comes to your website might have similar characteristics. So they might have clicked on your website from Google Ads, they might be using Google Chrome as your default browser, and they might have an IP address that is in India, a lot of other characteristics, right? So you can have a lot of population that has the similar characteristics, and those are not actually duplicate. That is how your data is. So it's a nature of your data and the problem that you are trying to solve. and then try to figure out why you have duplicates in your data. Is it due to class imbalance, whether there were some upsampling or synthetic sampling that was done before? This we will cover later, what class imbalance means and what it means to do undersampling or oversampling later. Feature engineering, feature encoding. So what feature engineering means is you have your data and you want to transform your data in such a way that it gives more meaningful output or predictions. So instead of having just age column, can you group it into a infantine, adults, and senior citizens? Or can you, if you have a date of birth, can you group them into Gen Z, millennials, Gen X, Gen Y, boomers, whatever, right? So can you group them? Because that will help you in some form of generalization based on your data. Again, taking the same example, if you're running a website, if you're Amazon, you might not want to know the age of each and every individual, but you want to group them into some category. So, okay, all the teenagers are buying this. Of course, it happens in some form of generalization, like how all the toys for girls are always Barbies, and all the toys for boys are always monster trucks. You have to be very careful where it becomes too much of a bias versus where it is required for your data. So, can transformation help in making your model much more robust? Um, One of the important things is that machine learning cannot handle text data. So it should it can handle only numeric data, and you have to transform your data to a numeric data, even your text column to a numeric data. And in doing so, you can use something called ordinal encoding. So in our, what ordinal means is it has a rank. So 1, 2, and 3 in our data doesn't mean like a red, green, and blue. It means like first class, second class, and third class, and there is a distinction. There is the ranking between the new numbers that you have, right? And then you have one hot encoding. So in your survivor or embarked, the 0 or 1, that needs to be transformed into a one hot encoding. What one hot encoding means is, let's say you have like a red, blue, and green kind of data. You need to convert it into a matrix that will for red, blue, and green. So from the column content over here, a vertical data, you're converting it into horizontal, you're making it into a matrix, where if it is red, then it is 1 over here, and 0 in blue and green. Similarly for blue, red will be 0 and green will be 0, but blue will be 1. So you construct a 0 or 1 matrix for your categorical columns. So that is what one hot encoding means. Again, dummy variable encoding, this is required only in case of linear regression. So for example, if you don't have any missing values in your data, instead of having red, blue, and green, you can just have red and blue. So if both red and blue are 0, it automatically denotes that it's a green. So linear regression, so the one hot encoding, it doesn't work for linear regression. But for any other machine learning model, it is okay. You can use one hot encoding. Okay, before moving on, so okay, so this we saw winning for ages. Let us look at another example. One of the things that we will often see is class imbalance. We will see what class imbalance means in later, but let's look at this data. This is a fraud data. In the sense, there are some fraudulent transactions that are happening, and we have collected some information about all those transactions along with a target variable or our objective to predict which is whether it is a fraud or not. So in this case, is fraud is our target variable. It will contain 0 or 1. If it is 1, then it is a fraudulent transaction, and if it is a 0, it is a genuine transaction. So we have 59,000 rows and 434 columns. It's a large data. And it has some column description. So we have transaction ID, we have whether it's a fraud or not, that we have like a transaction DT, amount, what product, what card, so on. Like you have like multiple, this is like card number, and like whether it's a MasterCard or Visa card, which browser they were using. So Firefox, Safari, etc. And this also contains like some missing values, and these are all like some questions, with a true or false answer, whether they are transacting from a desktop or a mobile, whether it is an iOS device or Android. So these are all the things that we have. So from these, we need to predict whether the transaction that a person is doing is a fraudulent transaction or not. Again, we are going to look into this. So if you look at it, only 2,000 out of the 59,000 are fraudulent transactions, right? So very, very less. So 3% of the transactions are fraudulent and 96% of them are not. So this is the distribution, and we have missing values in this. So yeah, so this is the percentage of missing values in each of the columns. So for example, if you look at this dist 2, you have like 93% of them are missing values. So these kind of columns you can drop already. The dist 1 is also something you can drop. But before you drop this, you might also check if there is something called postcode, or can you derive this dist column from address 1 and 2. For example, in most of the countries have their data open source. So in India, you can go and download the postal data from the data.gov.in, which will contain district, street name, city, state, etc. So can you look up from this address 1 and 2 and then impute your district 1 and 2, right? Things like that. And then our email domain is 76% blank. So you can drop all these columns. So here what you can do is you can probably set a threshold saying, okay, anything that has more than 70% missing values, those columns can be dropped. Okay, and yeah, we are going to fill the missing values with mode, most frequently occurring method. Okay, that's yeah. So after we impute it, we are going to like check whether we still have any missing values. So all of them are 0. So in this in particular example, we are not excluding this, but this is also something that you can try and see, observe. Every time you make an action like dropping a column or imputing it, you can see how your model differs, the prediction accuracy, whether it is going up or down. Okay, so yeah, coming to one-hot encoding. So what we are going to do here is for all the categorical columns, we are going to fill them with mode. And then we are going to use this function called getDummies. What this will do is in one shot, for the fraud data that you have and for all the categorical columns, it will create a dummy variable. So here, if you look at it, this is your original data with 434 columns. And then your output data has 667 columns. So this is after converting them with dummy variables. So yeah. So if you look at it, it is creating device info underscore RV54 underscore RV55, etc. So this means these for each and every column, each and every unique content in a categorical column, it is creating a column. So then if 56 is 0, others in this device info RV, all of them are 0. So this is what one-hot encoding does for you, is converting the categorical variables into a numeric variable while also retaining the meaning of the categorical variable. Okay. Right. So going back over here, few of the other things that you can do is binning. Yeah, this can be done for both categorical and numeric variable. And the objective behind this is to like make the model much more robust and prevent it from overfitting. So can you, of course, this also has a cost to the performance. So every time you bin something, you sacrifice information and make your data more regularized. So if you want to group everybody from 18 to 60 as adult, that covers a lot more age group in that, and then you lose minute information or learning that the model can have from that age group. So when you are winning, it is very important that you also keep in mind that the size of the bin is uniform. So these are the examples. So if you are going to take n is equal to 4, or n is equal to 8, or n is equal to 16. So number of bins is 4, 8, and 16. So this is how your data will be. So you will have 4 values, or 8 values, or 16 values. And yeah, moving on. So this is one form. Another thing is log transformation. So what log transformation does is, if your data is extremely skewed, then it helps in handling that. And after transformation, other important feature about this is the magnitude of order of the data changes within the range of the data. So for instance, the age gap between 15 to 20 may not be the same between 65 and 70, depending upon what problem you're trying to solve. So if you are trying to, let's say, predict survival from COVID, right? So the age gap between 65 to 70 is extremely significant compared to 15 to 20, because people with age greater than 60 are in a high risk zone, right? So that kind of differentiation is log transformation helps in understanding the magnitude of difference, and it also decreases the impact of the outlier. Another thing to keep in mind is that this log transformation cannot handle negative data. So if your data has negative, then you can like add +1 to it, and then do a log transformation. So this is something that you need to keep in mind. Scaling, right? So two types. One is normalization, and another one is standardization. So what normalization means is you multiply you divide x minus x minimum divided by x max minus x minimum. So what normalization helps is to help you compare data. Like for example, you have age and then you have income, and you want to compare these two. Say if the increase in age is also denoting an increase in income, so then that is something that you need to keep in mind when you are comparing two columns. If they are not on the same scale, you cannot compare. So normalization helps you there. Another way, help that this does is, if you are comparing two totally different let's say group of people, right? Like if you are comparing like people from India and their ability for their resistance or immunity towards COVID, versus another group from America, which is immune to COVID. So there also normalization helps. Again, standardization is this is based on the mean and standard deviation. You take a z-score, which is nothing but the difference with the the mean from the standard deviation. Again, and another thing is, before running the model, we need to split the input and target variable. So going back to this. So here what we are doing is we are separating the input features. So X is our input field. So we take everything except the is fraud column, because that's the target that we want to predict. And then Y is the is fraud column, the target variable that we want to predict. What we are going to do is we are going to use standard scaler, and then we are going to scale our features, right? So after doing the scaling, this is how the data looks. So the data, all the columns are scaled to be able to like compare. And splitting the data. So another difference you need to understand is the train, validation, and test split. When you get a data, you split them into train and validation. So train is what you create the model with. Validation is what you use to evaluate the model. So your model learns from the training data, and then you give the validation data to the model, and you test the model to see if it performs very well on this validation. So when you do this train and test validation split, you can do a 70-30 or 75-25. Again, it's a thumb rule. And another important point is you need to make sure that the train and validation is set at random. It's not carefully chosen, or you go by any of the category, like a male or female or something like that. You should always make sure that the split is random. Again, test set, this is what the model is completely unexposed to. So from validation, the model learns and then again trains. So it's a cross validation between train and validation set, and the model learns. But test is when you deploy the model, or before deploying, you test it with a completely new set of data which the model has never ever seen. Over here, what we have is X train, X test. So you're splitting the data into train and test. Similarly, you're splitting the Y variable, the target variable, also into train and set. The test size is 30%, which means the train size is 70%. You can also change this to like 0.25 or something else. And then imbalance data. Before moving on to this imbalance data, any questions, Chanakya, that I can take?
Yeah, we can probably take one question. Can you please be a bit more, can you talk a bit more about normalization and standardization, like when
Sure.
to use which scaling technique? Yeah, probably
Okay.
they want to know when to use which technique, standardization and normalization, and why.
Okay, sure. See, this you use on a numeric column, of course, and you use normalization and standardization when, let's say, your data does not have any, textbook definition of outlier, but you have some skewed data. Let's say, like for example, you are someone who target teenagers and you sell your product for teenagers, but sometimes the adults also buy from you. Maybe they are buying it for their some as a gift or something like that. They are buying it from their profile. You want to normalize that so that the skewness is not too much in your data, right? Like when I mean skewness, it is the dispersion. Like for example, if I go back to the this example, right? So this is a normal distribution. Sometimes this can also be so this tail can be something lengthy, and then okay, I can go back to this example, our age example, and like say, okay, here if you look at it, most of the population is from bin 1 to bin 6, right? Like what you see is thin tail between 7 to 10. If the data is skewed like this around bin 3 and 4, and like you have a lengthy tail over here, and you want to normalize this so that you fit it into this, right? So that you want to have a normal distribution with less standard deviation, then in that case you use scaling. And scaling is when sometimes when you are comparing multiple data sets, or when you have different skewness in different data sets, then it is better to use normalization.
Yeah, got it. Thanks. I think that's, yeah, we can maybe move on. Yeah, that should be.
Okay, sure.
Yeah.
Okay. We saw this. Okay, what is a class imbalance, right? What it means is we have a classification problem. So we want to predict whether someone survived or not, right? We have two classes there, 0 and 1, yes or no, fraudulent or not fraudulent, like what we saw in our example. In these two cases, your observation should be from both the classes on a balanced level. That's when the model can learn what it means to be a fraudulent transaction, or what it means to survive and not survive as well. So the model needs to be able to differentiate between characteristics, to be able to predict whether someone will survive or not in a better format. So here, in a survival or not survival example in Titanic, you may have certain characteristics. Like I told, they were evacuating women and children and senior citizens first. So in survived category, you might have these people more, right? Because that's what happened. And not survived might be people who were young but had like some precondition, like a respiratory problem, or people who cannot tolerate cold, frostbite, anything, right? So for a clear split between one category or one class and another, you need the data to be equally split or almost equally split. Sometimes that might not be the case. Why? Because the nature of the problem itself could be like that, right? So imbalance can occur due to biased sampling. For example, we have only sampled a lot from a single geographic location, or nature of the problem statement, like any fraudulent transaction like credit card fraud, etc. So it might mostly be like, like we saw in our data set, it could be anywhere between 1% to 5%. And then the imbalance could be a slight imbalance, like for example, the sex ratio, the gender distribution, as is in the country itself, is like some 55% to 45%. There you can't, try to like make it equal. So somewhere, some slight imbalance is fine, and you should like take it, because that is how it is in real life as well, or in your problem statement as well. Or severe imbalance, like claim prediction in an insurance or fraudulent transaction, chances of having like a thunderstorm in a desert, like those level of imbalance. And okay, what we will was a few things, the terms that you need to be familiar with. Let's minority class, the class that has few samples, and majority class, the class that has many samples. How to deal with class imbalance, right? We can do some resampling techniques. We can oversample the minority class, right? Like, so oversampling can be defined as adding more copies of the minority class. So you duplicate your data. So that's why when I was talking about the duplicate data, I mentioned that make sure the duplicate is not due to pre-treatment or pre-processing of the data. So you intentionally do more sampling from the existing data set itself, or add more same set of minority data, so that your minority class and majority class becomes equal. Or you can undersample the majority class, right? Undersampling, so let's say you have 2,000. In our example, out of the 59,000 records, we had 2,000 of them being fraud. So instead of taking the remaining 57,000, you can sample and take only 2,000, which is equal to your minority. So there you undersample the majority class. So you only take few of them. But the drawback is that we are removing some information that may be valuable. So you need the 2,000 that you select should have good predictability on your model, right? That's a little bit of a tricky part there, and this could also lead to underfitting and poor generalization. Another method is generate synthetic samples. So here we use Imbalance SMOTE algorithm, which is called synthetic minority oversampling technique. So SMOTE uses a nearest neighbors algorithm to generate new and synthetic data we can use for training our model. So let's say what it does is it tries to, instead of copy pasting the same data, like how you do in your oversampling of minority class, here what you end up doing is you create a synthetic sample. So let's say if by plotting the Titanic survivor on the graph and trying to find the nearest neighbors, the algorithm might find, okay, people who have survived have the age group of like let's say 0 to 35, or they have an age group of, let's say, 55 to 60. What it will do is it will create data from that range on how close it is to the nearest neighbor. right? So it is called synthetic sampling. Of course, these are also have some costs in it, in terms of generalization, or how much this should be near your algorithm. Can you control that knn, the k factor there, how many neighbors should be close to this, etc. Going back on the code. Yeah. So oversampling of minority class. So we use resample from sklearn. And then here, what we are doing is we are joining the data back together. Before this is something that is very important, is that you make sure both your target variable y as well as your input variable are in your data set before you do any resampling, because it should the connection between the input variables and the train is very important. It can't mix and match between train and the target variable. And then here, for the not fraud, because we are oversampling the minority class. For the not fraud data set, you are selecting where is fraud is equal to 0, and then fraud is where it is equal to 1. And then in the upsampled data, you use the function resample. You give your data set, which is your fraud, and then you replace it true, like sample with replacement. And then what you're saying is that the samples should be length of not fraud. So you want to match your fraudulent transactions as many number of not fraud transactions are there, right? So match the number of majority class. So once you do this, in the final, and then you join that with the not fraud and the fraud upsampled, and then the upsampled data has 1 and 0 together. So both of them have 39,000 now, right? So this is one way where both 1 and 0 have equal class split. And then downsampling. Here you do the reverse. You take the not fraud data and then you say match it to the length of my fraudulent transaction. So you downsample here. So it will reduce, or it will take in a random manner as many number of fraudulent transactions are there. So in this example, after downsampling, you have 1300 in both fraudulent and non-fraudulent transaction. Smart synthetic minority. So this is a direct algorithm that you take from Imbalance, and then here you give the sampling strategy as 1. So what this means is equal class split between 1 and 0. You can give 0.75 over here if you want to keep some of the class imbalance, or if you want can give like 0.6 as well. So if you want to keep that 60-40 rule instead of both are being equal. Yeah, and then you do the SM fit, the smooth fit, and then you have your and then you have your data. Let me show this. And let me also show this. Yeah. Counts. And yes. You have 39,000 in both. Any questions on this so far?
I guess there aren't any questions as such which are pressing. But yeah, people asked what is resampling and all, but I think you have already addressed that.
So resampling
maybe you
means from
can.
your existing data, you take more samples, or you replace your samples. So in statistics, what you usually do is you have something called population, your entire data set, and then you have your sample, which is like you take a portion out of it to do some testings. But in machine learning, we mostly use the entire data, but we split it between train and validation. And so what resampling means is that, like, are you allowed to take it from the resample from the same population or same set?
Yeah. And someone is asking, what is lag value?
Uh,
I'm not sure where it
lag
was
value,
used, but
or log value, or
yeah,
lag value? Few
I'm not sure.
seconds.
Maybe it's yeah.
Maybe we can take that
And
offline.
yeah, later on, yeah.
Yeah.
And someone was also asking, like, I have read a lot of papers that say oversampling is bad for our model. They don't recommend it to handle imbalanced data. Is that right? Or we can still use oversampling? So what's your take
It
on,
is. Yeah, it
yeah,
is true. It is true. Oversampling is a problem because what basically what you are trying to do is, like, naturally your data is split in like a 99% and 1%. But when you have to, like, so the problem with class imbalance is that when you have 99% of normal transaction and 1% of fraudulent transaction, a default prediction of 1 will give you a 99% accuracy, right? But you need to associate the cost with which you have to predict the I mean, I wanted to use the confusion matrix maybe in a after doing the modeling in evaluation of ML algorithms, that will be covered. What it means is, like, sometimes your accuracy is okay. What you want, maybe let me not use the jargons. What you want to predict is not always the right answer. You might want to predict a wrong answer correctly. So you want to predict the abnormal transaction with a 99% accuracy. So it doesn't matter if you raise a false alarm of a normal transaction. Most of the times, if you are swiping your credit card on a high transaction, you will get a call immediately from your bank to say, okay, did you make this transaction now? Right? It is okay if the transaction is normal and I make that call, but it is not okay if the transaction is fraudulent and I let it go. Right? See, that's the problem with class imbalance, is that it doesn't predict the minority class very well. So to be able to predict the minority class well, you have to either increase your data set a lot more, and then still the proportion will be somewhere between 95% to 5%. So you have to do this resampling to be able to improve your model so that the false positives are predicted well. That's why we also have synthetic sampling in case of oversampling, because oversampling is nothing but just repetition of the same data. So you might do a smart over oversample.
right? And also, while using one hot encoding, right, you end up getting a lot more columns. That might
Hmm.
also basically increase your computational cost as well.
Yes,
So
definitely.
someone was, yeah. So how do you trade off generally in a real world setup?
In a real world setup, okay, so that is why you need to. I made a comment in the beginning, is you need to be very sure of the column that you take into input for your machine learning model, right? So we call something as controllable variable and uncontrollable variable. If the model prediction is going to help in solving a business problem, the input variable, you actually, what you do is you trace the output of the model to the input variable, right? So that's how Amazon and Flipkart are targeting ads to you, to say, okay, you are of this age and you are living in an urban area, you're living in a metropolitan, you will be interested in Fire Stick, you will be interested in Kindle, you seem to buy a lot of physical book. So those kind of things, right? Like, so in that, you might want to drop the variables that are not making any sense from the business perspective, right? Like I said, whether someone is buying from a Chrome or a Firefox may not be an important input for predicting whether they are going to buy a Kindle or not. If they are purchasing a lot of books, or if they are have been browsing about a lot of books, or if they need textbooks or something like that, then those kind of variables makes more sense to include than to include a variable whether they have logged in from a Chrome or Firefox. So this is why business domain knowledge is very important in building ML model, as much as a math is required, so that you drop off the variables that are not making any sense, that are uncontrollable for business decision making, and then you use the columns that are required for the model.
Okay. Yeah. Got it. Yeah. Yeah. I think. Yeah.
Yeah.
We can. Yeah. I think right now it's questions time, right? So we are pretty much done with the session, if I'm not wrong. Yeah.
Yes. Yes. We are. Yeah.
Great. 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 Perfect. So, how to remove or check columns when there are a huge number of them? Remove or check. Yeah. I
Remove
think
or
this
check.
this you have already.
Uh, yeah. So remove or check columns is, yeah, of course you have to. Okay, one of the things that I did not cover here, but that is very important, is getting used to some data visualization tool, right? Like Tableau, Pandas, Power BI, or Matplotlib, Seaborn, whatever it is, right? You have to play around with the data on the data visualization tool to be able to understand how they are distributed, how the columns is. You can't scroll through like some 15 columns or 50 columns to know the data type and what it contains, etc. But if you are working on a data visualization tool, then it becomes easy for you to understand your data. Exploratory data analysis is a huge step. It consumes a lot of time. Going back to the pie chart, I think that's where the majority time happens. Time is being spent.
Right. True. True. Yeah. That's there. Also, we have another question. I think someone is asking what is X-train and Y-train. Can you please explain?
Yeah, sure. Sorry if I had skipped to that part. Maybe let me go back to this. So, okay, let me go back to the slide for. Yeah. So what happens is when we input this our data into the model, we input the data frame of the variable separately and the outcome separately. So we split the data into input and target. Right. So input is all the columns, like in our Titanic example, the pre-class, age, gender, embark, etc. And the target variable of was a survived column, whether they survived yes or no. Right. So when we build a machine learning model, when we say model.fit, we give this x, which is the input variables, which is all the columns, and then y, which is your target variable. Right. What train in that means is that is the set of data from your entire data that you use for training the model. So if I go back to that code again to explain, yeah. So here, X-train is the independent feature data for training the model. Y-train is dependent feature data for training the model. So X-train is the input, the corresponding Y-train is the output. So row by row, what you have here will have an outcome 0 or 1 in this. Similarly, you're splitting the test into the same X and Y. So when you do that, you also split them into train and test. You use train data to build the model and test data to validate the model. So that's what it means, X underscore train.
Right. Right. Also, I have sent something on chat, on the private chat. I think we spoke about uh, when to do data cleaning and imputation, everything, right? Do we need to do before splitting the data or after splitting the data? So
Okay.
maybe if you can throw some light there. Yeah.
Right. Yeah. So there. Okay. So if I go back to this slide, the data
Right.
cleaning should be done on the train and validation. Maybe I said test as well, but test is the data that is completely unexposed to the model. So your imputation and the missing values should be done on train and validation, and you deal with them, and then you expose this test data where it is not probably treated for missing values or
Yeah.
outliers, and see
Yeah.
how the model is behaving.
Got it. And we probably like now apply the same techniques, right? The data preparation techniques that we applied on trained data set, we would be applying on test so that that works on the model.
Right.
Yeah. Yeah. Cool. Got it. And we also have one more question. So, what is the best strategy when it comes to having, like, when you have an imbalanced class data set, right? So, what is the best strategy that you would go ahead with
See, there
typically?
is
It's a
not.
very broad question.
Yeah,
Yeah.
exactly. There is no one size fits all, because you need to like go with your uh, the problem that you are trying to solve as well. So
Right.
sometimes, yeah, personally, I don't favor oversampling, but
Hmm.
the idea is to start somewhere and then keep on improving. So, for
Right.
example, what you need to do is to, let's say, if you do you start with just taking the class imbalance as is, instead of splitting them 50-50, maybe you can do it 80-20, right? Or 85-15. You don't have to always make it like a 50-50, so that the model also understand that one class dominates over the other. And then you
Yeah.
can also try various combination in the smooth, in the synthetic. Maybe for just repeating the columns, you can move on to the synthetic. I mean, that itself is a topic for another day. Maybe we should
Yeah. True.
take
True. True.
that
Yeah.
separately.
Yeah. I agree. Yeah. It's all about experimentation. I think that
Definitely,
message
it's
is
all
conveyed.
about
I believe. Yeah.
experimentation. But today, at
Yeah.
least as a data prep 101, what you should be familiar with is that like this thing exists. Class
Yeah.
imbalance is a problem, and that's something that you need to be aware of.
Yeah. True. True. Yeah. Got it. I think we are pretty much done with the questions. So most of the questions were either addressed on chat or we picked them in between.
Okay, great.
Thanks a lot for that. But before we wrap up, Aarthi, do you have any message to the community based on your experience as an entrepreneur as well as a data scientist? Your
Uh,
learnings. You also are a accountant turned data scientist, which is not a usual case that we see. So
sure.
probably we would love to know more from your journey on that bit.
Okay.
Yeah.
Uh, well, there is no easy way, but practice, practice, and practice. But for me, accounting was my fundamental education. But when I joined EY back in 2009, I directly joined the data analytics team. Those days, data science was probably like still in a term that was not very familiar. I joined the data analytics team for EY, and there I had a chance to pick up SQL and some of the other programming languages that we can use for doing audits. So what that means is like when you apply the data science skills on a specific problem that is close to your heart, like that you are familiar with, and the problem statement that you can associate very well with, then you start understanding the data science much more intuitively. Probably from my background, if I had started with like a biostatistics or something like that, it wouldn't have made sense. I would have probably given up long back, because I don't understand biology. But because it was on the same field, or in the domain knowledge where my background comes from, it was very easy for me to connect the dots and understand the math intuitively. So for example, I keep talking about credit card transactions, but that's what we use in audit to mark fraudulent transactions in like a purchase or a sales or payment to a vendor, or tax payment, or employee bonus. Is there like any fraudulent transactions there? So once I start connecting the machine learning skill or data science skill to the problem statement that I understand, it was actually much more easy from there. And then a couple of other things came only with practice. Like, because when I started in 2009, linear regression, logistics regression were very popular. We did not go beyond that, or ARIMA for time series. And then in 2012, I guess, when Kaggle was getting popular, 2012 or 13, then XGBoost was a something that was everybody was craving about, because it was giving like some zero 0.9 accuracy in the Kaggle leaderboard. And then you have now deep learning, and then now it's easy to buy a GPU machine in
Yeah.
collab or things like that. So the problem is, you have a lot of resources. If you are stuck with the code, if you are having some problem, I mean, for example, today, before getting started on this, we were adapting an older code to a newer code because some function was deprecated. You just Google it, you get it. But domain
Right.
knowledge and practice is what makes you distinct, not whether you remember a syntax or whether if you have like a zero 0.9 in a Kaggle score. I mean, of course, Kaggle is important for practicing, but being able to solve a problem using data science is where you will learn a lot more. And that's when your curiosity to ask more questions or approach people who have already done that and gain from their experience also happens.
Yeah, true. Totally aligned. And thanks a lot for the
My pleasure.
wonderful piece of advice. Also, there is one more question that we have. This is more on generic terms. So, how to? Someone is asking. Just give me 1 second. I think I just missed it. Yeah, how to overcome experience requirements apart from general projects we all do. How to get the interview call? Quite challenging when all are after this field these days. Any
Oh,
tips
this
on
is
that?
not just problem for a fresher. It's also a problem sometimes for the experienced people. Is that like there is sometimes the word data science in a job description attracts a lot of applications, whether the person thinks they fit the job description or not. So because of that overcrowding, it's very easy from a recruiter's point of view to ignore you, even if you have a great skill. To replace experience to begin with, I would say be very confident and thorough with your math and statistical knowledge, and also be able to like connect the dots. It's okay if you don't solve a problem from a retail industry or pharmaceutical industry, but if you take a COVID data or if you take a crime data for a city, can you make sense out of it? Because general knowledge and news is something that we all follow, right? Like for example, we talk about first lockdown, second lockdown in Europe. There are some positive things as well compared to first lockdown and the second lockdown. Now the death rate has come down, right? The death rate in Belgium used to be the highest with 14%, and now that has come down. So are you able to infer knowledge from the data? That is very important. And the best way to demonstrate that is please start blogging a lot or write a lot, publish Kaggle kernels, have your code in GitHub. Please don't be shy whether it is perfect or whether it is great. The first step is to try and show that you are trying, because sometimes when people recruiters land on your blog or your GitHub, from your very first GitHub to your latest repository or very first blog to your latest blog, they see how much you have evolved, how much you have learned, which shows your grasping skills and passion towards this field. So that's something that I would personally advise. I mean, when I started, those things were not there. I still have like some died down Kaggle profile, which I stopped touching after 2015. But it is very important to do it today, where you have some place where you showcase your knowledge.
Yeah, totally aligned, and I think that definitely helps.
Mhm.
And I think with that, we are pretty much done. And thanks a lot, Aarthi, for the
My
insightful
pleasure.
session. And I believe like people can connect to you after this session on LinkedIn or on
Definitely.
Slack.
I'm
Yeah,
there on
yeah,
the Slack or
yeah,
LinkedIn or,
yeah. Great,
yeah,
great,
yeah.
perfect.
Thank
Yeah,
you so much. Thanks for this
thanks,
opportunity.
Aran.
And yeah,
Yeah, thank you. It's our
thank
pleasure. Thanks a lot. There is a lot of thanks pouring in out there,
Okay.
and thanks,
I mean,
thanks a lot. Yeah,
yeah, my
yeah,
pleasure. My pleasure.
and
Okay.
yeah, thank you, and
Bye
take
bye.
it. Yeah,
And
bye.
take
Yeah,
care, everyone. Stay strong in this COVID times.
yeah. Thanks. Bye.